All right, guys, for this video, we're going to do a lot of what we just did with the rational zero theorem, but we are going to use the TI Nspire to find the zero so we can kind of eliminate the rational zero theorem. You can kind of see it here on the notes. Well, what does the graphing calculator allow us to do? We can eliminate that whole plus or minus P over Q. That got to be a little bit tedious. You know, you listed the possible rational zeros, and then you would do synthetic division. And if you didn't get the remainder to be zero, you kept doing it over and over again. All right. So what we're going to do right now, we're just going to do this first one. You can see it's a degree of 5. So I want to get the zeros, and I want to do synthetic division 3 times so I can get this degree of 5 down to a degree of 2. All right, then I could factor or use quadratic formula to get the last 2 zeros. So if I can use the graphing calculator, I'm going to put this equation on the TI Nspire, which is what I'm going to do right here. All right, so here's the TI Nspire. Right, you go on graphing. I put this exact equation in. I hit enter. And then the zeros are these 2 points. They're the x-intercepts, which looks like it's at -2 and 1. Now, if I wanted to check, because sometimes the zeros are a decimal, to find the zeros, this is where I can hit menu on the TI Nspire, 6, and then 1. And if I wanted to find this zero, which looks like it's at -2, when it says lower bound, I click on it. Upper bound, I move it to the right, shade it, and there it is. That's a 0. So that means I'm going to use synthetic division. I'm going to put -2 as a number in the top left corner. All right, this one right here looks like it's at 1, but if I want to check it, I'm going to do menu, 6, and then 1. Right, lower bound means I move it to the left of that 0. I click on it, and then upper bound, I move to the right. And there it is. It's at 1, 0. All right. Now, I did say that this degree is 5, so that means we have to use synthetic division for it 3 times, but there's only 2 zeros. But the key is this one, it bounces off the x-axis, so that means this is a double root. So I'm going to have to use synthetic division twice for the x equals 1, and I'm going to have to use synthetic division only once for this x equals -2. All right. So I'm going to go right to using synthetic division for -2 and using it for 1. So I can eliminate the whole plus or minus P over Q. So I'll get out of here. So what I'll do right now, let me go to drawing. Let's put this in blue. So I got that first 0 to be at -2. And I'm just going to put these coefficients down here. So it's 1x to the 5th. There's no x to the 4th, so I have 0. Then I have 1x cubed, 2x squared, -12x, and 8. Now I should get this remainder. I should get this to be 0 right here. All right, so let's do synthetic division. We bring down the 1. -2 times 1 is -2. Add here, we get -2. -2 times -2 is 4. 1 plus 4 is 5. 5 times -2 is -10. 2 minus 10 is -8. -8 times -2 is +16. Then -12 plus 16 is 4. 4 times -2 is -8, and it works out. All right, I get that remainder to be 0. All right. Now, the other zeros I got was the bounce. It bounces off of x equals 1. Now, this, by the way, I started with x to the 5th. This here is x to the 4th. So I have to do synthetic division 2 more times to get that bottom line to be a quadratic. All right, so I'm going to bring down this 1. So 1 times 1 is 1. -2 plus 1 is -1. -1 times 1 is -1. 5 minus 1 is 4. 4 times 1 is 4. -8 plus 4 is -4. -4 times 1 is -4, and see how it works out. 4 plus -4, they cancel out. That's my remainder of 0. So this is 1x to the 4th minus x cubed plus 4x squared. Actually, excuse me, this is x cubed minus x squared plus 4x minus 4. Now I have to do synthetic division 1 more time to get this bottom line to be a quadratic. So I'm going to put 1 in there because that's a double root. There was a bounce on the graph. So I'm going to bring down this 1. 1 times 1 is 1. Add here, and it cancels out, so it's 0. 0 times 1 is 0. 4 plus 0 is 4. 4 times 1 is 4. Add these, and that's my remainder of 0. All right. And you could do it if you started off with 1 using synthetic division and then you end with -2, you should still end up with this 1, 0, 4. So this is the quadratic we're left with. So here's what we've proven so far. By looking at the TI Nspire, we knew that -2 is a 0, so therefore its factor is x plus 2, right? Just using the factor theorem. Now we've proven that 1 is a 0. Now it bounces off it, so it's a double root. So since this occurs twice, the factor for it's x minus 1. Since it occurs twice, we have it as squared. And then this last quadratic, this is x squared plus 0x plus 4. We don't really need to write that 0x. So this last factor is x squared plus 4. So to find the last 2 zeros, we have to work with this. Now this doesn't factor because it's a sum of 2 squares. It's not a difference of 2 squares. I wouldn't want to use quadratic form because there's no x. So the easiest thing to do is we could just set this equal to 0 to find the last 2 zeros. And then if we set it equal to 0, x squared would have to equal -4. And then we could take the square root of both sides. And then this is where we get plus or minus. Now, normally if it's just square root of 4, we get plus or minus 2. But since we have a negative inside the square root, this is where we get I, right? We get the imaginary number. So the last 2 zeros are imaginary. It's plus or minus 2I. All right. So all the zeros, we got plus or minus 2I. And then from looking at the TI Nspire, the other zeros we got were -2 and then 1, and that was a double root. All right. So that's an example right there. You first just want to graph it on the TI Nspire, and then all the zeros that you get, which were in this case -2 and 1, then use synthetic division for it, get it down to a quadratic, and then solve for that quadratic. In this case, they were imaginary zeros.